Hello there, geometry genius. Yes, that's you. We're going to take a look at proportions in triangles. Having dealt with similarity with triangles and polygons, we're also focusing specifically with right triangles as of more recent days. Now focusing specifically with the proportions in triangles and the select theorems or patterns that come up with triangles, and those being proportionate to each other. So what's our objective? To use the side-splitter theorem and the triangle angle bisector theorem. Those are very wordy, aren't they? So we're going to be using those two to notice the proportions that come up in triangles. So we're using the side-splitter theorem and triangle. Two angles here, triangle angle bisector theorem. So we'll go right into it. First thing first is this theorem seen here. I'll give you a moment to copy this and then we'll chat about it. So pause the video and we'll talk about this. You pause the video, right? You copied this, right? Hopefully you did. So the side-splitter theorem is saying that if we have two or more parallel lines intersect each other, the proportional segments are formed. So in this theorem, if a line is parallel to one side of a triangle, for example here, RS being that side that's parallel, or maybe it's XY, who knows, then if they intersect the other two sides, then it divides those sides proportionately. Yeah. So seen here, RS is parallel with XY, allowing us to create this proportion of X to R over RQ, and how that should be proportionate to YS over SQ. So X to R is here, R to Q is here. This over this should be equal to the small on the right over the larger on the right. So notice XR is small, YS is small, RQ is definitely bigger from the visual, same with SQ. So let's take a look at some examples that show this. So with this, we have a triangle, same kind of setup as before. And we're being asked to find the angle of A in the diagram at the right. Well, I know that the side-splitter theorem says that if we have a line running parallel to a triangle and they intersect, that the segments there are going to be proportionate. So in this case, I know that this segment here, this A plus 4, could work with the A, which is the top part, and that should be equal to this 18, which is the bottom right, over the top right, so 18 over 12. Cool, seems easy. So we can take this further. Not quite a geometric mean like we saw in the previous section, but we can still cross multiply, see what happens. So we get 12 multiplying with A plus 4, and this should be equal to 18A. We can distribute, so we get 12A plus 48 equals 18A. If we deduct 12A on both sides, take this up here, 48 should be equal to 6A, dividing both sides by 6, A should be equal to 8. So that answers this. It's going to be 8. We'll skip the reasoning part. Maybe we'll talk about it in class. That takes us to the corollary to the side-splitter theorem. Let's take a look at that. Which is saying if we have more stacks now, so notice we have 3 parallel lines that intersect 2 transversals, those segments intercepted on the transversals are proportionate. So it's pretty wild how this one works because it looks as if this is a ladder of sorts. Maybe that's a good way to think of it. But ABC runs parallel. Those three lines run parallel. Pretty easy to understand that. Have these two lines, or transversals rather in this case, that cut through, creating A, B, and C, and also WXY. So we can say that AB should be over BC, and that's proportionate to WX over XY. Pretty simple for that. We'll try this one out. We have this set up here, looking for the site C. This looks like a campsite. Summer's coming up soon enough, right? We're allowed to talk about that. So we have these three, what would be 4 lines cutting through these transversals. So maybe rotating this will help us out, which is saying that this up here, this is 9 yards. Make this a little bit more noticeable. Make this 9. This is 7.2. This is 6.4 and 8. So if we were trying to find the length of site C along the road, well, I know that we could set up, just based off of these bottom two, a proportion like that. So let's see that. So I know that we could set up 7.2. I'll switch back to a normal pen. We can do the 7.2 over the question mark, and that equals 8 over 6.4, because they're both on the left side. These are both on the right side. Pretty simple to understand that. All right, well, let's take this further. 7.2 would multiply with 6.4. This equals 8 times that question mark. I can use a calculator because I'm not afraid of getting my arithmetic correct. So let's take 7.2 times 6.4, 46.08. And if we divide by 8, we see that the length of site C should be 5.76 yards. Easy, easy, easy stuff. Sorry about that. Here we go. Yeah, you probably want to see that. There you go. All right, cool. Got it. We'll take this further for the triangle angle bisector theorem. Good amount of information in this one. This is saying that if a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. So in this case, AD is a ray that bisects an angle of the triangle. So notice here we're allowed to say that CAD is going to be congruent to DAB. That might be important to make a note of for this one. Sketching this out also so I can get a better visual of it in case I need to reference it. And then we're allowed to say that CD over DB equals CA over BA. Cool. Easy stuff. All right. It's nothing we can't handle. Make sure I copy that right. Yeah, we're good. All right, let's do this one. Last one. Let's make it happen. So we can assume that this is going to be using triangle angle bisector theorem because this ray is creating these 2 congruent angles, which allows us to then say that if we take the fraction of 9/0.6 over 16, this should be equal to y over 24. Let's cross multiply them. 9.6 and 24 should be equal to 16y. Where's my calculator at? 6, 24, 230.4. Great. And that should be equal to 16y. So let's divide it by 16. 14.4, sounds good. Call it a day. Fun stuff. If you have any questions on these three theorems, bring them to class. We saw the triangle angle bisector theorem, creating two congruent angles here and proportions accordingly. Saw the side-splitter theorem, and then we saw the corollary to the side-splitter theorem, which really just adds another layer of a parallel line. Nothing too crazy here. If you have questions, bring them. Thanks for watching.